Hey there, we are starting 11, Unit 11. We're going to start talking about some sequences and series here. It's just really just patterns, but fancy ways of talking about patterns. So a sequence is just your list. It has a pattern called a series when you're going to add them up. Not that big of a deal there. But writing your terms, literally the first 5 terms, you're just taking first, you plug in 1 right there for n, and you find out what you get. 4, then you plug in 2, 3, 4, 5. You get these numbers. It's not that big a deal. You can even plug some of them in as exponents. But we'll do that a little bit, but it's not that big of a deal either. You just plug your exponent in and see what kind of numbers you're going to get. So here we're going to get our first 5 terms. So we're going to plug in 1, 2, 3, 4, 5, and so forth. So a sub 1 is going to be 1 minus 2, which is negative 1. A sub 2 is going to be 2 minus 2, which is 0. 3, you're going to go 3 minus 2, and so forth, until we get to the 5th one here. So, whoa, all of these guys here are our answers for the first 5 terms. This one is doing the exact same thing, only now we're plugging in here in an exponent spot. Not that big a deal. So a sub 1 is going to be 3 to the 1 minus 1, which is 3 to the 0, and hopefully remember that anything to a 0 power is just 1. A sub 2 is going to be 3 to the 2 minus 1. And I'm going to just put the rest of them in here. And there's the rest of your numbers. It's just going 3 squared, 3 to the 3rd, 3 to the 4th, and giving you these guys here. Alright, so this thing here, sigma. Sigma stands for summations. Is what you're going to use. I found it a little bit easier if we think about things like this. So here's my sigma. From this to that, do this. So it's going to give you a number down here. From this number to that number on top, you're going to do this, which is going to be your weird little expression. 2x plus 5, or x squared, or n minus 3, or whatever it is. From this number to this number on top, you're going to do whatever it says in here. So here, from 2 to 4, so there's 2, 3, and 4, every number from 2 to 4. What are they doing? They're adding 6 to it. So you're going to add 6, you get these, you put them together, and you got that. It's your summation. So same stuff's going on here from 0 to infinity, so you can imagine that going out forever. Blah, blah, blah. From 2 to 6, so here we're plugging in 2, 3, 4, 5, and 6. All over top of the rest of our fraction. You put your fractions together. A big ugly answer. No, I'm not going to make you do that. Although I should. I don't know why we wouldn't. I think we could do that. Alright, so we're going here from 1 to 5. This literally means 2. It's not I like we remember I, the imaginary number. It's just 2 times your number. So we're just multiplying it, twice whatever the number is. So for 1, it's going to be 2 times 1. And then you plug in 2. And 3 and 4 and 5 and so forth. So we got 2 plus 4 plus 6 plus 10, and all that adds up to 30. So our summation of 2i from 1 to 5 is 30. Okay, not so bad at all, right? It's even easy. Easy. Alright, so same thing here, except we're going from 3 to 6 this time. So we've got 3 minus 1 plus, next number would be 4 minus 1 plus, and there you go. So that's a 2, a 3, a 4, and a 5. Easy, easy, easy. Alright, this one's where it gets a little bit tricky because math and all. So there's the first one. Let's throw the rest in there. Like so. So we've got our number plugged in each one. Just doing the same thing over and over again. Negative 2 here plus 5 is going to be a 3. Negative 4 and 5 make 1. Negative 6 and 5 make negative 1. And negative 8 and 5 make negative 3. All that comes out to a big 0. Nothing. Alright, I think you guys can kind of work through the rest of these on your own, so I'm going to throw them in here for you to look at. So the thing here is that since you've got an x and an x, we're plugging every number in here twice and just working it out on down. Alright, same thing here. Just plugging in our numbers. Boom, 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 doubling every one of them, add them up, get 20. Alright, so writing our expression. The 1 down here means we're starting at 1, so this is the first one. We plugged in 1. So that means we plugged in 2, 3, and 4. Since 4 was my last one, 4 is going to go here. Now I'm going to think about, these are all fractions, so I'm going to write my fraction. How do I get from a 1 to a 2 that's the same as 2 to 3 and 3 to 4 and 4 to 5? Hopefully we're thinking that you're going to add 1. K is my letter down here, so I'm going to use K. And then the same idea, how do I get from 1 to 3 and 2 to 4 and so forth? That's going to be K plus 2, because you have to add 2 to get to the numbers on the bottom. And we've written our first summation. Look at that. Alright, so first thing, second thing, and so forth. So, number them off here, and all we're going to do is plug 1 in here for K and see what we're going to get. So I got negative 4 minus 3 times 1. Why did I make that negative? That's just 1. Times 1. So we got negative 4 minus 3, which makes negative 7. That means 3 and 3 down here are both bad. Don't pick them. So, next one we need to pick is going to be plug in the 2. Negative 4 times negative 3. Or minus. Oh, goodness. That's just bad. Oh, I apologize. Negative 4 minus 3 times 2. Just plug it in here. Negative 4 minus 6 makes negative 10, which is what we have here and not here. So B is your answer. And your summation problem here is kind of like what you might see on your test. Just remember, this is the first one, since they all say K equals 1, 2, 3, 4, and 5. So all we want to do is find one that's going to alternate, making things positives and negatives. If I leave this one here, that's not going to work because negative 1 squared is not going to be negative 2. It's just not going to happen. So here, and the same kind of things, plug your stuff in and A is going to be the one that works here. So we get negative 1 to the 1 minus 1 times 1. So many ones here. So plugging it in for both of these. That's going to be a 0, so this goes away and becomes 1 and just leaves us at 1. So we're going to go negative 1 to the 2 minus 1 times 2. This becomes negative 1 to the 1, which is just a negative, leaves negative 2. And if you keep plugging them in, A is going to be the one that works every time. And that's all we have. So, see you in the next one.